0.174 and H value as 8.722. So the critical radius of insulation, we can get it RC, which is equal to K by H. Okay, so the moment critical radius of insulation is asked, immediately you can do that. Okay. Is it visible?
Yes, sir.
Yeah, one minute.
Yes.
Yeah, now please wait. Let me take my pen. Hello, am I audible?
Yes, sir.
Yes, sir.
Okay, RC, which is equal to critical radius of insulation equal to K by H. Okay, that we know that. So the K value is 0.174 and 8.722 is the H value. So 0.174 divided by 0.1747. 0.174 divided by what is the H value?
322.
8.722 mark.
Sorry, sir.
Okay, what is the critical radius of insulation? How much you got? The value?
0.019, 0.019, sir.
0.019
5.
meters, right?
Yes.
Is it correct or not?
Yes, sir.
Yes, sir.
Okay, so the critical radius is 0.019 meters. Okay, now what is given in the question? The question given is a wire of 6.5 mm dia at a temperature 60 degrees C is to be insulated. Okay, so the temperature is 60 degrees C and the ambient temperature is 20 degrees C. Okay, so convective K value and H value is given. What is the minimum thickness of insulation and heat loss per meter length? Okay, also find the increase in the heat dissipation also. Okay, so the first one is the wire as it is there. Okay, without insulation you have to solve. Okay, the first one first one Q1 is without insulation. Without insulation. So without insulation means there is no insulation. Okay, so the formula becomes, what is the formula? We know that only the wire, the heat transfer takes place between the wire and the wire of dia 6.5 mm and the surrounding atmospheric pressure. Surrounding atmospheric air. Okay, am I correct?
Yes.
Hello.
Yes, sir.
Am I audible? Am I correct?
Yes, sir.
Yes, sir. Yes, sir.
So Q, which is equal to HA del T, or Q equal to del T divided by 1 by HA into H into A. Now the area. Okay, what is the length given? Length of the wire is given. Is it given? Per meter length. Okay,
No, sir.
for 1 meter length it is given. So we know that, I rewrite it again. Q equal to del T divided by 1 by H into area. What is the surface area of the cylinder? Wire can be assumed as a cylinder. Pi dl, right?
Yes, sir.
Pi dl or 2 pi rl? 2 pi r1 into L. So now substituting the values. So what are the values? The temperatures. The temperatures were 60 degrees wire temperature, ambient temperature is 20. So 60 minus 20 divided by 1 by h. The h value we already know that. Okay, so the h value is 8.722. 8.722 into 2 pi into R1. What is the initial radius of the wire?
0.00325.
Dia is 6.5. Okay, dia is given. So 3.25 mm radius. Okay, 3.25 mm radius. So 3.25 into mm. So convert it into meters. 10 power minus 3 into 1. So this is the heat dissipated in the first case. Okay, students, how much you are getting?
5.61.
5.
61 K by W.
No, it won't be in K by W. Q value it is.
W by M.
Sir,
What?
sorry, sir. It's 7.13 watts.
7.13. That's correct. 7.13. What year? See, if you calculate like this, you won't get any marks in
No, sir, no, sir.
Cat 1.
I calculated the R separate first. That's why I got confused.
7.13 watt per meter. Okay, per meter length. This is the okay. So this is the first case. So in the second case, what happens is you have critical radius of insulation to increase the heat transfer. Am I correct? Am I
Yes, sir.
correct, ma?
Yes, sir.
Okay. Now in this case, what happens is Q, which is equal to del T divided by, here you have conductive resistance as well as conductive resistance. Okay. So convective resistance is 1 by HA into the outer radius. Now you should take the outer radius. The critical radius is the outer radius. Okay. 0.19 is the outer radius. Okay. So HA into area is nothing but 2 pi RC into L. Am I correct? Am I correct?
Yes, sir. Yes.
Yes.
Plus the conductive resistance, natural log of R2 by R1, where R2 is equal to RC, R1 equal to the initial radius of 3.25 mm. Is it right?
Yes,
Is
sir.
it right,
Yes,
students?
sir.
Yes, sir.
Okay. Divided by 2 pi KL. Conductivity 2 pi KL. Is it correct?
Yes, sir.
Yes, sir.
Okay, now substitute it and get the result. Take down this del T divided by 1 by 2 HA into 2 pi RC into L. Now, here you should note in second case, R2 equal to RC. Okay. Okay, students. The problem is
Yes,
first,
sir.
initially the wire is without insulation. The second case, it is with the critical radius of insulation. Is it fine?
Yes, sir.
Yes,
RC
sir.
equal to RC. Now find out and get the result. Q equal to del T. Again 60 minus 20, the numerator 1 by HA into 2 pi into RC. The critical radius, how much we got? We got around 6.6. How much mm?
Which one, sir?
Critical radius 0.019 meters. Okay.
Yes.
So substitute 0.019 and get the result. Do you want me to solve it, or you can tell me the result?
So result is 15.6 watt per meter.
15.6 watt per meter. All of you got that, ma? 60 minus 20. Is it visible? Everyone?
Yes, sir.
Yes, sir.
1 by HA into A. What is H value?
8.722.
8.722. 2 pi into critical radius is 0.019 meters. Okay. 8.72. Is it correct?
722.
722, sir.
1 by HA into 2 pi into RC. 0.019 into 1. Okay, plus conductive resistance also. Natural log of R2 by R1. 0.019 divided by what is R1 ma? How much mm?
0.00325.
0.00325. Okay. Natural log of this. Okay. Divided by 2 pi KL.
Yes, sir.
What is the K value? Conductivity given.
0.174.
Conductivity is 0.174. Conductivity is given in the question as 0.174. All of you are able to understand this?
Yes,
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 sir.
sir. Yes, sir.
Okay, find this separately. Okay, this one separately, and find the result. What is Q2 with insulation?
15.6.
15.6 watt per meter. Okay, now what is the percentage increase they are asking? So percentage increase is Q2 minus Q1 divided by Q1 into 100. So 15.6 minus, what is the initial value we got? 7. 7.13.
7.13.
7.13 divided by 7.13. How much it comes? Percentage?
About 118.
118 amma?
Yes, sir.
118 point, how much?
0.2.
118.2 percentage. Okay, so almost there is 2 times when compared to normal wire, when you insulate, almost 2 times, more than 100 percentage. Is it fine? Is it fine, students?
Fine, sir.
What happens when
Yes,
you
sir.
don't have insulation? Okay, when you don't have insulation, the heat transferred or the heat given is 7.13. But if you have the critical radius of insulation, you have 15.16. Okay, so the difference between the previous problem and this problem is, in the previous problem, okay, initially it is having a that is 0.8 mm thickness insulation. Okay, then you are asked to find out the critical radius and what is the heat transferred with 0.8 mm thickness and what is the heat transferred with critical thickness. Okay, but here in this problem, the wire is not having insulation and then the wire is having insulation. That is the difference between these two. All of you are able to understand this? Students,
Yes,
is
sir.
it fine,
Yes.
ma?
Yes, sir. Yes,
Yes.
sir.
Okay, yeah. So now you can solve the problem number 10. Okay, and you tell me the answer next class. I don't want to waste so much time on in solving this numerical. Okay, the same type. Okay, K by H, you will be getting the critical radius, and then you have heat loss is given from the 475 Kelvin body. Okay, 60 mm dia pipe. What is the to the surrounding atmospheric air? Okay, so the surrounding atmospheric air is 300 Kelvin. Okay, so Ta minus Tb. Okay, so 475 minus 300, and you can find out the same procedure. Okay, the same procedure, ma, like the problem number 11, you have to solve problem number 10. Is it fine? Sorry,
Fine, sir.
problem number 12. Just like problem number 12, you have to solve
Yes.
problem number 10. Is it fine, ma?
Yes,
Fine,
sir.
sir.
Yes, sir.
All of you will be doing it, right?
Yes, sir.
Yes, sir.
I'm doing, sir.
Okay, fine, thank you. The you have to find out what is the heat transferred without insulation and what is the heat transferred with insulation. Okay, is it fine, ma?
Fine, sir.
Yes, sir.
Okay, ma. Now we have composite wall, composite cylinder. We have discussed. What about composite sphere? The heat transferred by a composite sphere. Okay. Now we know that. See, composite wall. We know that, right? Heat conducted. We have got the we have discussed about the resistances and all. Am I correct?
Yes, sir.
So we have in case of composite cylinder, okay, we have the convective resistance, conductive resistance, and convective resistance. Am I correct?
Yes, sir.
Is it visible?
Yes, sir.
Visible, sir.
Is it visible?
Yes, sir. Yes.
Okay. Similarly, in case of composite wall also, we have a composite wall which is made of 3 layers, and you will be having convective resistance on inner side and outer side, and similarly you will be having conductive resistances depending upon the number of layers. Okay, 3 layers means 3 conductive resistance, 1 layer means 1 conductive resistance. Okay, am I correct?
Correct, sir.
And similarly, we also discuss about the composite wall, okay, series parallel composite wall, and we also solved 1 or 2 problems how to get the series parallel composite, that is resistances. Am I correct?
Yes, sir.
Okay, now the third case is sphere. Okay, so how to get the value for sphere? Okay, now it was mentioned here 1 by r square d by dr into r square dt by dr is the general heat conduction equation, and the temperature distribution and heat flux is given with by this formula. Okay, so especially the heat transferred is 4 pi k del T divided by 1 by r1 minus 1 by r2. Now how you get this? Most of you have did 1 or 2 that is experiment number 2, I think. In the laboratory, I think the experiment number 2 you will be having that, I think so. In liquids you might have used that formula, I think so. Okay, anyway, in the laboratory the professor will teach you. Okay, now let us discuss about, yeah, the experiment number 3, I'm sorry. Most probably you will be having that experiment number 3 this week, okay, and the process will be teaching you. Now assume that you have a sphere. Is it visible?
Yes, sir.
Okay, let inner sphere and outer sphere. Okay, so it's not a cylinder ma, it's a sphere. Inner radius r1, outer radius r2. Okay, so now we know that q, which is equal to minus k into a into dt divided by dr. Am I correct?
Correct, sir.
Okay, now q equal to minus k into area. What is this area? Anybody? So assume that the inner sphere is T1 and outer sphere is T2 at a temperature. Okay, okay, students.
Okay, sir.
Okay, now purely talking about conduction. Okay, so inner sphere is at a temperature T1 and outer sphere is at a temperature T2. Okay, now what let K be the thermal conductivity of the material. Okay, and now what is the area, ma? Surface area of sphere? Area. In school, in mathematics, you might have studied.
Pi r square.
Pi r square?
4
4
pi,
pi
Sphere.
r square.
4 pi r square.
4 pi r squared. Okay, now again, let me rewrite it. Q equal to minus k into a. Instead of a, let me write 4 pi r squared dt divided by dr. Okay, so this dr goes to the other side. Q dr, which is equal to minus 4 k into 4 pi r squared dt. Okay, this r squared, okay, it will go to the other side. Q dr by r squared integral r1 to r2, which is equal to minus 4 pi k into integral dt t1 to t2. Okay, now q, when you integrate it, it will be r power minus 2 plus 1 divided by minus 2 plus 1. Am I correct, students? Am I correct?
Yes.
See, please tell me if I am wrong. I am not that much great in mathematics. Okay. For minus 4 pi k into temperature dt it is T. So upper temperature, upper limit is T2, lower is T1. Okay. So r power minus 2 plus 1 divided by minus 2 plus 1. So what happens here is r power minus 1 here. Q into minus r power minus 1. So this I can rewrite it as so when this minus sign goes inside, what happens is this becomes q into minus of 1 by r2 r1, which is equal to minus this minus sign goes inside, so it becomes 4 pi k t1 minus t2. Is it fine, students? Is it fine?
Yes,
Yes, sir.
Okay. Now finally, let me rewrite it again. Q into minus 1 by r. Please tell me the q into minus 1 by r, r1, r2 as the limits upper and lower, which is equal to 4 pi k into t1 minus t2. Am I correct, students? Am I correct or not?
correct, sir. Correct.
So q into minus 1 by r2 minus, so take this minus sign outside, 1 by r2 minus 1 by r1, okay, which is equal to 4 pi k into t1 minus t2. So when you include this minus sign inside, it becomes q into 1 by r1 minus 1 by r2, 4 pi k. Am I correct or not? Please inform me if I am wrong. Am I correct?
Correct, sir. Correct.
So q, which is equal to 4 pi k into t1 minus t2 divided by 1 by r1 minus 1 by r2. So what it becomes is r2 minus r1 divided by r1 r2. In some expressions they will be writing like this. So this is the final expression for heat transfer. So the final expression becomes q equal to del t, t1 minus t2 divided by r2 minus r1 divided by 4 pi k. This 4 pi k comes to the bottom, r1 r2. Is it fine, students? Is it fine?
Fine, sir. Sir,
Yes, sir.
but the 4 pi k, like, doesn't matter if it's in the denominator.
You can see here. Here for cylindrical, sorry, spherical wall, 4 pi k del t 1 by r1 minus 1 by r2. I got the expression right. 4 pi k del t 1 by r1 1 by r2. 4
Yes,
pi
sir.
k del t 1 by r1 minus 1 by r2. They have stopped with this. 4 pi k del t is t1 minus t2, 1 by r1 minus 1 by r2. Okay, so see the extended form only I have written. Okay, so what happens 1 by r1 minus 1 by r2, it becomes r2 minus r1 divided by r1 r2, and then when the 4 pi k comes in the denominator, it will become r2 minus r1 divided by 4 pi k into r1 r2. Is it okay?
Fine, sir.
Is it fine or not? See, this is the one you will be discussing in experiment number 3. I think experiment number 3, insulating powder, thermal conductivity of insulating powder. Okay, even in today's class, this week class, I will be doing it. Okay, even when you look into the manual, heat transfer lab manual, yeah. For experiment number 3, they have given this. So that's why heat transfer, whatever you study the theory concept, you will be doing it in lab also. So that will be very much useful for you students to understand the concept as well as so insulating powder, we will be finding it out. Yeah, this is the two spheres. Okay, so when you look into this, so instead of R1, R2, they might have mentioned uh, R0 and RI. Is it fine? Can you see here how to get the
Yes, sir.
so
Yes, sir.
q equal to this value 4 pi k R0 RI. So into del T divided by R0 minus RI. That's the formula. Okay, they have used here. Okay, so that's what whatever you study in the theory, you will be doing it in the lab also. Okay, so this is the expression for what's that composite sphere, right? This is the expression for composite sphere. Now you may ask a question, sir, what happens if inside you will be having a liquid at high temperature or low temperature, and outside you will be having surrounding air? Then you will be having the you will be having the conductivity, sorry, convective resistance also, right? For example, if you have, assume that you have a cylinder, sorry, you have a sphere. Inside you will be having, assume that you have some liquid, okay, which is at a very less temperature, and you will be having the spherical wall material, okay, and you will be having outside air, TB, air, outside air. Okay, so now this inner temperature you can take it as TA, and you can involve Q, which is equal to del T divided by 1 by HA into A plus whatever expression we got now. What is the expression we got? Where we have, wow, yeah, 4 pi k. Okay. 1 by R1 minus 1 by R2 divided by 4 pi k. 1 by R1 minus 1 by R2 divided by 4 pi k plus 1 by HP into area. So here the area, inner area is A1, outer area is A2. A1 will be equal to 4 pi R1 square inner radius, and A2 is 4 pi R2 square. All of you are able to understand this, students?
Yes, sir.
So inner radius is R1. Okay, so the fluid, the inner fluid is acting on the inner layer, and the outside air is acting on the outer surface. Okay, so the air will be acting on the outer surface. So 4 pi R2 squared. Okay, the inner liquid will be acting on the inner surface. So inner surface area is 4 pi R1 squared. All of you are able to understand this?
Yes, sir.
Yes,
Don't
sir.
think that sir is somewhat writing some expressions, and uh, all of you are able to understand this, because I have completed around 50% of module 1, sorry, module 2. All of you are able to understand composite wall, cylinder and sphere,
Yes, sir.
Yes, sir. Fine, sir.
because this is the easiest topic in this module. Entire heat generation will be tougher, please understand. And one of the student, he said, sir, you are saying this one is the easy? Yes, really, this one is the easiest one. Okay, remaining other things and all, it will be slightly tougher than this. Is it fine? Shall
Fine,
I
sir.
solve one problem?
Sure, sir.
Yeah, you have this problem, a spherical vessel. Let me copy it and paste it in the chat box. Hello,
Yes, sir.
am I audible?
Yes, sir.
Is it visible, ma, to all of you? I have copied and pasted it in the chat box.
Yes, sir.
The question. Okay. So see, as far as sphere is concerned, I will be solving this one, and if time permits, I will be solving the next one, or otherwise you have to solve the next two. Okay. Don't expect me to solve each and everything in the class. Next class, I will be going on to internal heat generation. I'll be try to solve the problem, students. Okay, don't wait for myself to solve all the problems, because if you try that, that is if you want me to solve, then we will not be able to complete all the modules. Please understand that. Okay, what is a sphere inner radius? Spherical vessel 1.4 meter dia is 90 mm thick. Okay, a spherical shaped vessel of 1.4 meter dia is 90 mm thick. Find the rate of heat leakage if the difference between the inner and outer surface is 220, and what is the other thing given? Thermal conductivity.
K equals 0.083.
Okay, now now what is uh, the outer radius? The outer radius is 1.4 meters. Okay, see, all of you, sometimes you people, you have the tendency to take this one. Okay, so the outer radius, the spherical shaped vessel of 1.4 meter dia is 90 mm thick. Okay, so now what you have to do is the thickness. The thickness is 90 mm. Please wait a minute, ma. 1 minute. Hello, am I audible, ma?
Yes, sir.
Okay, ma. See, actually, the problem is today the Code Tantra got crashed, and most of the students, they started the exam by 10:30. That's the problem. Today there was a that is the situation is not good. All the students, first year students, there was some problem. Okay, ma. So the dia is 1.4 meters. Okay, so R2 will be equal to 1.4 divided by 2. It is 0.7. Sorry, 0.7. Am I correct?
Yes, sir.
Okay. Now R2 minus R1, which is equal to 90 mm, 90 into 10 power minus 3. It is 0.09. Am I correct? Meters. Am I
Correct.
correct or not? Okay. So which implies R1 will be equal to 0.7 minus 0.09. How much it is? 0.061 na? Sorry, 0.61 na?
Yes, sir.
Am I correct or not, ma? Please.
Correct, sir. Correct.
Okay. Then now we have got R1 and R2. We don't have the whether the inner surface temperature is inner fluid is temperature is given and outer fluid temperature is given in the problem. It's not given. Am I correct? Am I correct or not?
Yes, sir.
Just the
Yes, sir.
difference in temperatures del T is given 220, and similarly the radius is given R1 and R2, and thermal conductivity is given. K is given as 0.083, R1 R2 given, and del T given. Am I correct? Now we can find out the Q. Q, which is equal to, we know the formula, del T divided by, what is the one I have written? Where is that? It's not there. What is the formula, ma? No one knows the formula. All of you are there or not? I don't know. 1 by R1 minus 1 by R2
divided by 4 pi k.
divided by 4 pi k. Am I correct?
Yes, sir.
Am I correct or not? No one is answering.
Yes, sir.
Correct, sir. Correct.
220 divided by 1 by R1. What is 1 by R1, ma? Is it 1 by R1 minus 1 by R2? Am I correct?
Yes, sir. Yes.
Yeah. 1 by 0.61 minus 1 by 0.7. Divided by 4 pi k. Thermal conductivity is given as 0.083. How much the value, ma? Final answer?
I'm getting around 1007.
1000?
1007.
No. What about others? Only one person is doing the calculations. Remaining others are sleeping, I think.
1088.
10?
88.
1088. What about others? One of the person is saying 1007. The other one is 1088. Which is the correct answer? Which one is the correct answer, ma?
So I get 1151.
Ah, 3 answers. 1151.
Sir, 1088.6693.
Okay,
Yes.
it's in between the first answer and third answer. So let me write 1088.
Ah, yes, sir, correct.
Yes, sir,
1088. Is it
Point-
correct?
Yes, sir. 1088.
1088 point
Point
0.67.
67.
0.6.
Ah, okay.
Okay. Okay, ma. So like this, you have to solve. Okay, we have another 5 minutes time. Let me give the introduction about the next problem also. So in this problem, all of you have taken this answer 1088.6.
Yes, sir.
Yes,
All
sir.
of you have taken the step, students.
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
So in the next problem, it was mentioned as it is a thin spherical wall metallic container used to store liquid hydrogen at minus 196 degrees C. Okay, the container has dia of 0.5 meters and is covered with insulation composed of silica powder. The insulation is 25 thick. Its outer layer is exposed to 27 degrees C. The convective heat transfer coefficient of the outer surface and inner surface is the convective heat transfer coefficient of the outer surface is 20 and K value is 0.07. What about the convective heat transfer coefficient inside? Inside it is given. Inside it is given, ma. For liquid nitrogen, whether they have given?
No, sir.
No, sir.
Okay. Only outside is given. Okay. So actually, for technically speaking, this problem, they should have given the inner one also, but since they have not given, so many messages. Okay, now we have the dia is 0.5 meters. So R1 and R2. So R1 is 0.25 meters. Am I correct, ma? Am I correct?
Yes, sir.
And
sir.
Yes, sir.
it is covered with the insulation of silica powder. The insulation is 25 thick. So R2 minus R1, which is equal to 25 So how much it is? 25 na 0.025, right? Am I correct, ma?
Yes, sir.
Because these small 0 point, instead of writing 0.025, if you write 0.25, the whole answer goes wrong. That's why I am checking you once again. So R2 will be equal to 0.25 plus 0.025. So how much it will be? 0.275
Sir.
meters. Okay. Now we have the inner fluid temperature TA and outer temperature TB. TA nitrogen temperature. And TB air temperature. What about air and nitrogen temperature ma? Minus 196 and 27. Am I correct?
Yes, sir.
Yes, sir.
So minus 196 and 27. Now where the heat transfer will be, it is from inner side to outer side or outer side to inner side. So you will be getting the answer in minus. Why it is so? Because the heat is transferred from the outside to inside, but we assume the heat flow as inner side to outer side. Okay, so TA minus TB divided by what is the expression? The expression is 1 by R1 minus 1 by R2 divided by 4 pi K va plus 1 by HA, sorry, outer HB into area. Outer area is 4 pi R2 squared. Is it right, ma? Students, is it right?
Yes, sir.
Now substitute and get the result. Minus 196 minus 27. So you will be getting the answer in minus. So the heat is absorbed by the system, not heat is rejected by the system. 1 by R1. So radius R1, R2, now I have to check. R1 is 0.25 and R2 is 0.275. Point 0.275 divided by 4K va. What is the thermal conductivity? 0.0017. Okay, so this is the first resistance. Okay, students, all of you are
Yes,
there?
Yes, sir.
Yes, sir.
And similarly substitute 1 by HB 4 pi R squared here. Substitute the values and 4 pi R2 squared. Convective heat transfer coefficient outside is given. Outside is mentioned as 20. 1 by 20, 4 pi into 0.275 whole squared. What is the final answer you are getting? Please tell me. See, HB is given ma, R2 is given. Substitute and get the result. This is conductive resistance or conductive, and this is convective resistance. Students, is it visible ma?
visible, sir.
Here substitute HB value and R2 value. R2 is 0.275, HB is it is mentioned as 20. So 1 by 20 into 4 pi into 0.275 the whole squared. So that is convective resistance. And finally find out what is Q. What is the Q value ma?
Sir, what's the HP value?
Yeah, what is the final answer ma? All of you are there?
Calculating, sir.
Yeah, do it fast. How much time it needs here? You need. What will happen if I ask this type of problems?
Minus 13.06.
Is it correct?
Yes, sir. I'm getting the same.
Minus
13
13.06 watts. So students, some of the students were getting minus 13.06 watts. Okay, so please check the value. Okay, so try to solve the third problem also. So now which problem you have to solve? You have to solve problem number 9 and problem number 10.
10.
Okay, problem number 9 and 10 you have to solve, and you have to tell me the answers tomorrow. Okay, so let me download the attendance.